So we're on the Potomac River and we're looking at the history of the Potomac River incising into the rock of the Piedmont, trying to figure out when that happened and how it happened.
Well, this is the Potomac River Geomorphology field trip, and I was interested in it because that was my primary field of interest when I was in graduate school. So I wanted to come back and see what my colleagues had learned about it since I went to school.
On this trip, it's fun. I've been actually here before with Paul, the trip leader, and really just kind of seeing how his work has changed the kind of picture of incision here on this river since I was here. So,
I should say that this landscape is very close to sea level today. I mean, sea level is sort of lapping up on a lot of the places that I was drilling.
The conditions that are conducive to weathering vary quite a lot across the channel cross-section.
Over 50% of the variance in the Schmidt hammer, just the measured rock strength, can be explained by the variability in the numbers of visible cracks that we can see.
I'm a geologist at the University of Vermont. I've been studying the Potomac since the late 1990s, and I run a geochronology lab where we measure the ages at which rocks are exposed on the surface. And through that, we can tell the history of the Potomac River over the last several 100,000 years.
We think of the eastern United States as being this very old, passive margin that not much is happening on in terms of its surface processes in geomorphology, but in this trip it's showing that the erosion of Great Falls is in fact quite rapid, and we have a lot of geomorphic activity over very short time scales.
So that photo is to show you what this place looks like at 160,000 plus cubic feet per second. So basically the entire falls is submerged. If you look at the flood record, I think this is a 5 to 7 year event. So it's something that happens repeatedly in a human lifetime. This gorge fills up and looks like that. They're dramatic falls, so they've attracted attention since George Washington's day. And we're trying to bring some science to the understanding of when these falls formed and if they're changing today and what their history was. The rates of erosion in Mather Gorge and near Great Falls are on the order of the rates of erosion people have measured in the Himalaya. So they're really, really fast over short geologic periods of time. Grab some food, we'll be out for almost 2 hours. We'll be back here just before dark and then we'll go to dinner.
So as we were walking down here, you might have noticed that the further down we went, the more bedrock exposure we had, and the channel steepened and the hill slope steepened.
We learned all about the exposure history of different terraces and tried to figure out exactly how the river is incising into the landscape over time.
You've all made it to the last stop of the trip. If you look up, you see Mather Gorge. If you could look down a couple kilometers, you would see Carter Rock where we had lunch. And we're right at that transition phase in here. Really broadening the horizon, showing them new landscapes. We have a number of people on this trip from the West who've actually never seen this kind of eastern geology and this kind of eastern landscape. So think about it as broadening people's horizons.
It's just breathtakingly beautiful, and also nobody knows exactly how it formed, and that's one of the things that Paul's doing with his cosmogenic dating of the terraces here.
We have a set of measurements and we don't know how we got to those concentrations. And I think you then have to apply your best geologic insights and what you know of the place, and basically take your best guess at that time, put the data out there, and who knows what, your students and my students are back here 50 years from now. Maybe they'll look at the same data with a completely different lens.